if 5 more people buy Unity this month, then we're good. But if 5 fewer people buy Unity this month, then we're done. They made like 3 real-time demos of like a car, a tiger, and something else, and no one understood what these are, except it's something to do with game development. I do remember starting to joke that we are turning into IBM any day now, as soon as the company grew to like 15 people. And at some point, everything became so much sort of schedule and Jira driven that there's no Jira ticket saying randomly decide to go to forums today. I think Unity at this point is still the most widely used engine ever. There's not much experience at all in the world in how to continue developing an engine like that. I hope that Unity can get out of the current slump and get back to being a nice and pleasant to use and easy to use and highly polished engine that doesn't try to go after AAA or doesn't try to compete with Unreal. You can just wish them good luck and hope they find a way.
Hello everyone, my name is Wookash and this is Wookash Podcast. And this time I'm joined by Aras Pranckevičius, a first non-co-founder employee in Unity Engine. We talk a lot about how Unity worked back then, how it changed over the years, and what engineering marvels Aras was doing back then in Unity and is doing now in Blender and other open source software. Join us.
So I started programming around 96 or 95. And I started programming because my father got me a ZX Spectrum as a birthday present.
Okay.
This was when the rest of the world has moved on from ZX Spectrum, but me being in Eastern Europe, this wasn't an actual ZX Spectrum even. This was like a Soviet stolen copy of a ZX Spectrum and a Lithuanian copy of the Russian copy of that. Anyway, so this was a nice machine that he had 48 kilobytes of memory and could load programs from a cassette, and you could write programs in BASIC or in assembly for that. These were basically two options that you had. And I remember that the very first thing I typed out of some book that also my father bought from like a library or whatever, I don't know. The very first thing I typed from the book, it generated a picture on the screen of like red and white checkerboard probably, or something like that. And that was so amazing that I thought, I want to do this for the rest of my life and like generate pictures on the screen with code.
Okay.
Yeah, that's how it started basically. So I must have been 15 years old or something like that at the time. So I spent like 2 years on the Spectrum until I got my PC. So that was like an enormous jump in capabilities going from 48 kilobytes of memory up to, I think that was like 4 megabytes of memory, which was like amazing.
Nice. And then it was C?
Then it was Pascal. Yeah, for a while, until one friend at school convinced me to learn C because he was like, yeah, Pascal has no future or whatever, and all the cool kids with C or whatever. Yeah, and then it was C, then C++, and then after a while I got a job, which was Java at the time.
Okay.
Java still exists, right?
Of course.
Yeah.
Of course.
Yeah, I just been out of Java land for like 20 plus years. So
Yeah. It had a change because it changed from free and open in general into more like paid version, and now there's other companies like Oracle has the paid version, but you can have also for example, Amazon is doing the free version of Java.
Okay.
So it's like complicated world now.
My knowledge of Java. So back then it was Sun who owned Java, and I knew that Oracle owned Java now, but what happens with it, I have no idea.
Okay. So what did you do before joining Unity in terms of professional work?
So it was like regular software, like databases, backends for like some, I don't know, that was like 2001 to 2005 or something. So I spent several years doing like Java, C# as well, just like regular software. And then I was involved in one games-related startup. That was before startup as the word existed, I think. And we were basically trying to do what Microsoft later did with Kinect, sort of a vision-based input system for games, and make a game along the way. And of course, back then you also needed to make an engine along the way, because like an engine that you can just use didn't exist as a concept.
Yeah.
So we spent, me and some friends from either high school or university spent about 3 years doing that. Of course, it eventually didn't go anywhere whatsoever until the whole thing shut down. But it was fun, sort of, for a while. Then I went back to doing regular software development until I joined Unity.
Were you drawn to games and game development?
I guess so, to some extent. Like I don't remember being so much drawn into game development as much as computer graphics. Because as I mentioned, sort of, I saw this checkerboard on screen, and that was like the coolest thing. And of course, in the 90s, everyone was playing, Doom 2, and later on Quake and Warcraft, and I think Transport Tycoon, and sort of these things, and these looked cool and great and sort of inspiring, I guess. But working on games as such, I don't think I ever was that much interested into that. Like the technology side was more interesting to me.
Okay. So then you joined Unity and you stayed there for 15 years, and you've seen this company going through various stages. So let's start with the beginning, chronologically. How it looked like in the beginning, and then we're gonna talk maybe how it transformed and changed, and probably we're gonna like mess up the chronological aspect of the discussion here and there.
So one of the things that actually convinced me to join Unity, because initially I declined the offer, because the offer was like, you get an email from some guy you've never heard about, from a company you've never heard about, making a game engine. And I think the email that I got said like, come work with us on the future of games middleware. And of course you read such an email and go like, yeah, good luck, sort of. Idiots, or whatever, right? And it was in a different country. And back then it was a Mac-only engine. And me being a Lithuanian in 2000, this was like before iPhones existed, right? I don't think I've ever seen a Mac before, actually. So I was like,
this was Mac-only engine?
Yes, it was a Mac-only engine. And this is a very strange business decision to launch a Mac-only engine before Macs were cool, before hipsters were invented, right? But I think it might have helped them because there was no competition whatsoever. It was the only engine for a Mac, more or less. So all the 10 people who wanted to make games on a Mac used that engine, right?
Okay.
It was a Mac-only engine because the founders, for some reason, had Macs and were using Macs, and that's what they knew. Anyway, back to beginning. So one of the reasons then convinced me to join, because initially I declined the offer, but then they invited me for a game jam, sort of, and I went for a game jam. And I think the CEO at the time, David, met me outside of their office, and I think he was wearing a pirate hat for reasons.
And I was like, triangle one?
Yeah.
Okay.
And I was like, this might be cool. And this looks like a trivial or whatever thing, but just the thought that this might be cool was, I think, enough to convince me to join. Of course, I thought it would just crash and burn and go nowhere in a year or two, but at least it would be fun while it crashes and burns.
Okay, how many people had the company back then?
It's complicated. So there were 3 founders, but one of the founders was away at making a game in another company that was using the engine. So he wasn't sort of working on the engine at the time. So you could say it would be 2 people plus 1 intern doing his master's thesis. And then I joined. So that would be like, basically in the office, it would be 4 of us sitting there.
And everybody was in Vilnius?
No, this was in Copenhagen.
Okay.
It's Unity is a Danish company, even though the founders are not actually Danes.
Wait, you moved based on this appearance of the guy in a pirate hat. You moved to the country to work in a company with 3 other people.
Yes.
Nice. Talk about adventure.
Yeah, and I think I took like a pay cut compared to my previous job as well. And Copenhagen is not a very cheap place to live either.
Yeah. Okay. Nice. That was a jump then. Okay. So what was that in the beginning? What were your tasks? What you needed to do? How the company organized itself?
So the initial email that offered me a job was like, oh, you will work on graphics, you will work on Xbox 360, because Xbox 360, I think, was just about to launch, or maybe it was just launched or something like that. But of course, that didn't happen. So initially, I worked on Windows support, or more specifically, Windows web plugin support. Again, that was the time when browsers had a concept of plugins. Now they don't anymore. And just like Flash used to be one of the popular plugins, Unity also had a web plugin where you could build a game and sort of just build it for the web plugin and play it in the browser. These days, you can do that with like WebGL or WebGPU and WebAssembly. But back then, none of these things existed. So I initially worked on the web browser plugin for Windows, for Internet Explorer and the other browsers, because of course these are different plugin APIs that you need to use for them back then. And after that, I worked on graphics things. I worked on Direct 3D support, because initially it was OpenGL only, being a Mac only engine. And back then, OpenGL drivers were not that great on Windows, shall we say.
Okay. So you worked on making Unity de facto cross-platform, first through the web plugin and then through the actual Windows native solution.
So sort of you could build games for Windows already when I joined. It wasn't like great or anything like that. But addition of Direct 3D, back then Direct 3D 9, fixed a lot of sort of stability issues and some of the performance issues. And then later on in 2009 or 8, I don't remember, I worked on making the actual editor work on Windows as well.
Okay. And then the company positioning was that Unity is sort of a toy engine, or was it more like directed into the professional, like professionals are who are using Unity? Like what was the game?
I think the positioning was that sort of, you could call it like a prosumer market, or I think the term indie was just about being invented at the time. So it was positioned as, you could imagine something like people who would use Flash for 2D things. This is like 3D.
Okay.
For like smaller teams, smaller games, indie studios. I think even at one point on the website it said the most powerful engine this side of $1 million, because back then Unreal Engine 3 existed and no one knows what, like the licensing costs for that were not public, but the numbers I've heard were something that, like $1 million per title or something like that.
Okay. And so talking about licensing, Unity back then tried to have like a license model where you're just paying per seat of license, right?
Yeah.
And maybe we can here break a bit the chronology, and then I will ask you like more open-endedly. What do you think about financing Unity, financing engines as, generally speaking, a business? You know, like selling game engines as business. Unity, had this rough parts in a couple of last months or years, and they're turning much into more advertising, and they have the revenue. Obviously, Unreal Engine is owned by Epic, and Epic has Fortnite, and this is also connected. So what do you think about financing a game engine?
So my memory is that when Unity was very small, it was somewhat profitable, actually. This isn't the public impression of people are saying that Unity has never been profitable or something like that, but their data goes only like a couple of years before the IPO happened. Now, like back when company was under, say, 50 or 100 people, it was breaking even, sort of. It wasn't hugely profitable or anything, but sort of it had a tiny chunk of sort of profit, which was mostly constantly reinvested into the engine itself, in terms of, now we can afford 2 more people or something like that, right? When I just joined, I remember like the CEO was saying that, we just made 10,000 euros a month. Like, yay. And now, initially, Unity didn't even have a free version at all. It only had 2 versions, like Pro, and I think it was called Indie. And Pro was like, I don't remember, over 1,000 euros, and Indie was like 200 euros or something like that. And we only made the free version several years down the line, maybe in 2009 or 2010. And that was a very scary decision for a company to make, actually, because like you assume that, yes, if you have a free version, that will grow your user base, of course, but by how much? Or will everyone just switch to the free version and no one will pay at all? Like, you have no idea, right? And with increased user base also comes a lot of sort of will the support forums just become unusable due to all the influx of the users or something like that. So yeah, that was a scary sort of decision to make, but my memory is actually fuzzy now. Like, whether did that happen after Unity got the first like Series A investment or before that? I think it happened after, and I think part of the reasoning for getting the initial investment was to be able to afford this, to be able to make the free version to begin with.
Okay.
But again, I might be mixing up dates. I remember that these happened close in time, but which one was the first? I don't actually remember right now. Okay. But going back to your question, I think it should be possible to have a fairly small company making games technology or like game engine, shall we say, that would be decently profitable. Now, I don't know whether such a company actually exists today. There are some companies that are making commercial game engines. I have no idea whether they are profitable or not. My guess is that the large ones, being Unreal and Unity, are not actually making profit out of the engines right now, primarily due to the size of the teams and size of the investment that is going into the engines. Like, even with all the layoffs, I would imagine there's 500 people working on Unity, the engine, or something. And they might be profitable if there were like 100 people. But can you make Unity with 100 people? I don't know.
Okay. So coming back to the story, you joined the team that was something of a 4-people team, and worked on Windows alternatives for Unity engine and editor. Then the team started to grow, and I can wrap my head around game engine development when you have 4 people or like 10 people. I don't know what happens when you have 50 people, for example, or 100 people, and now you need to ship like one thing. It needs to be cohesive. You need to make sure that everybody's aligned, and I guess there are problems with communication, especially.
Yes.
So what happens then?
Chaos, madness, nothing works, nothing is cohesive, no one knows how to communicate, and no one communicates effectively, and then you're done. So, or more seriously, I do remember starting to joke that we are turning into IBM any day now, as soon as the company grew to like 15 people. The joke was on me, though, because after John Riccitello was no longer the CEO, the interim CEO they got came from IBM. I think that within any team or any product, as soon as you grow to something like 5 times the previous size, everything starts to break and nothing works, and then you need to get out of that crisis. And then you find ways to make it work until you grow 5 times more, and then there's another crisis again. So like, if you're working on like 5 or 10 people, then sort of up until about 20, 25 people, you can just sort of use the same approaches. When it reaches past 20 something people, then all of a sudden nothing works. And then basically you need to somehow start to specialize into have more than one team or something like that. And it's no longer the case that everyone knows everything that is going on. So past that size, you start to have teams which focus on some specific area of the product. And then when you grow to about 100, then nothing works again. And then maybe you need some managers or some producers, or how you call them.
Yeah. Well, I'm interested in how did you technically split the engine? Because I can imagine, for example, in the web development world, when you have microservices, it's going to be like, here's a contract. I'm going to have this microservice. You're going to have this one. We exchange a JSON, and like it needs to have these fields. It's very direct split. And then in the engine, you have, this is all one binary. Like it's more closed. Maybe now it's being a bit more modular in the Unity world, but back then it was just one thing. So what have you used for, technically speaking, to like separate the work?
I don't remember it being that big of a problem, actually. Just the fact that sort of it's one code base. I mean, it's kind of what some people who even do like very modularized or like microservices or whatever things. I mean, some companies or some teams still choose to use like a monorepo approach, where technically all the source code is still in the same place, and you check out the whole source code, for example, and you build all of it yourself, right? Even if you're not working with some particular part of the source code, you just never go there and you never read it. So the fact that the source code as a thing was not very modular, like, yeah, it could have been more modular, but I didn't notice that being a big problem, actually.
Okay.
At least initially, a much bigger problem used to be that we didn't have a single build system. So that meant that when like the people who are working on a Mac add a new source file, they add it to like the, back then Xcode didn't exist either. So like they add it to their like Code Warrior project, and then Windows build breaks because the Visual Studio project doesn't know about that source file. And so
Okay. So there was no issues, for example, that there was like a class that was reused everywhere, and somebody thought of an idea to actually rename the class, and everywhere now it's like changed, and then some things that were not connected remain with the old version of the class that were reading this from a file and stuff like that.
Oh, no, actually, in a monolithic code base, you almost don't see that problem, because since you build the whole thing yourself, I mean, if you rename some class and don't rename all the usages of the class, then your own build breaks. So the fact that it's not modular is actually helping in this particular aspect.
Okay.
It's not helping in the aspect that, for example, you still need to build everything, even like for example, I don't know, random example. I've never worked on audio or something like that, but I still need to compile all the source files over and over again.
Okay. How did the compiling time change over the years for Unity?
Well, it got slower, of course.
To what degree?
It was never very bad, but also we once in a while we would invest in sort of trying to get the compile times down when they became like worse than they used to be. But I don't know, like I think when I left, that was like 3 years ago, I think building the whole editor and the like standalone player support was taking maybe, I don't know, 15 minutes on a decent workstation, like from scratch. Of course, if you just edit one file and incremental builds are much better. So 15 minutes is is way slower than some code bases that are extremely fast to compile, but it's also way faster than the time it takes to build like LLVM or Chrome or Unreal Engine. So,
Okay. So when you started to specialize, like there were teams formed, the boundaries, I assume, were formed. There's this law, I think it's a Conway's law, that your organization enforces the same structure in the code. So like if you have an audio team, you will have your code will have like an audio module that would be separate from the visual module that like rendering stuff, where you have teams that are separate, right? Like the what I'm trying to say is like, structure of the teams will be visible through the modules and boundaries within the code. Did this happen?
Maybe, but I don't think it matters as much as I don't remember the name of the law, but like there's this law that you ship your org chart to your users. Which has nothing to do with the code itself. It's that your users experience your org chart and can tell which teams never talk to each other when they should. Because like in Unity's case, you can see that for many, many years, the Universal Render Pipeline and the HD Render Pipeline teams never talked because they would name the same things different names and invent sort of their own ways of achieving the same thing. And that's much worse problem than how the source code looks like, because especially for closed source products, no one cares how the source code looks like. I mean, it could be all written in Fortran and no one would give a shit, right?
Yeah. Okay. On that note, Unreal Engine source code is now public on GitHub, and Unity has now modules that are open, but they are modules, and the core engine remain closed.
Yeah.
What do you think are the advantages of this, like public source code style of Unreal, and whether it applies to Unity or not? Would it help Unity situation?
If I were a king of Unity for one day, I would make the source code available in similar terms like Unreal is. My personal take is that the way Unity keeps the core engine source code private, like you can actually license it. It's just doesn't come for everyone, right? I think that there's like, they call it enterprise license or source code license or something like that. So if you really, really need it and really want it, then you can get the source code.
Okay.
It's just not free and not cheap. Now, I don't think there are advantages for keeping it closed at all. Because my impression is that during game production, you will run into some issues, and some of the issues, they will not be properly documented, or no one will know what is actually going on. So at least being able to read the source code, not even to modify it, but just to read the source code, is very useful in finding ways or explaining why something is happening. Now, once in a while, especially towards the end of the game production, you might want to make some hacks or some workarounds to the source code just to be able to ship. And that doesn't mean that the engine is bad or anything. It just happens everywhere. So once in a while, people would want to modify the source code just to ship, right?
Yeah.
And again, they can. It's just expensive.
Okay. But you don't see this as an advantage, for example, for developers to have closed source code so that they can remain with their own abstractions or like half-baked code here and there. Like this doesn't strike as an advantage.
In my view, no, it's not an advantage. And I mean, even for publicly available or open source projects, there's still a bunch of things that are half-baked or hacky
yeah.
or not pleasant at all. That's fine.
Okay. Unity has this abstraction, for example, for game objects, right? And if you want to add logic, you do this through C# scripts, and you hook up you override particular methods like start or update, fixed update, that are called by Unity engine.
Mm-hmm.
And this is done to make the game development easier, simpler. On the other hand, if you know what you're doing and you don't have the access to this sort of like underlying for loop running through the engines, and you know that it's there, but you don't know how game objects are stored and things like that, it's because of the closeness of the source. It's a bit both annoying, but also can stop you from doing things that you would have done if it was open. I was wondering, is it possible in an engine like Unity that is now so big to rewrite these core abstractions to make them faster, better suited, for example, for the vectorized operations for new CPUs?
In my mind, vectorized operations have nothing to do with that question.
Okay.
But we can discuss that on a separate thing. But if the question is, can the engine itself do drastic optimizations, essentially speeding up everyone's projects by a factor of 10 or whatever, right? In some cases, yes. In some cases, no. So there's this thing that whatever API or whatever design you ship, people will start to use it and will start to depend on things working exactly as they are right now. So if you do pure performance optimizations, like, that are essentially achieving exactly the same result, and just, the code is faster, that's fine. But if you want to restructure something, then usually that would cause a new design to happen or new APIs to be exposed. And again, that's possible to do. Is just even like, without breaking everyone's projects, you could just expose a new way of doing things that is faster or more optimal or whatever, and keep both APIs working and everyone's happy. The downside is that it becomes a mess, right? So after, I think this summer, Unity turns 20 years old since the first release. Over 20 years, you keep on adding new ways of doing things, and eventually you end up with what used to be like the like OpenGL or whatever, right? There's 7 ways of doing things, and 4 of them are deprecated, 2 of them are slow, and 1 of them is maybe fast. And when we're not even gonna tell you which ones are which, right?
Okay.
So Unity, for example, tried or is trying to do that with a whole dots thing, which is like data-oriented technology stack, I think it's called, where they have an entity component system and everything is supposedly multi-threaded all the time, and all the data layouts are actually very nice for the CPU caches, and very fast to load, very fast to instantiate new objects. And all of that is good. It's just essentially it creates a new engine inside of existing engine. And that's a valid approach, but it does increase the total complexity.
Yeah.
Because now people have to make a choice. Do they use game objects, or do they use the entities? And I think Unity is trying to somehow merge them together or to unify them in some way. But at least until very recently, these were very separate worlds.
Okay. You mentioned dots, and I maybe will ask a couple of questions about features. I know you left Unity a couple of years ago, and if you don't know or if you can't tell me, that's fine. But I want to preface this like dots to me is a very interesting project. I think Mike Acton was leading this for at least a couple of years. He's no longer employed in Unity. And I think, to my knowledge, Dots has not seen 1.0 release until this day.
It has.
Is this like an official way now of doing things in Unity, or?
It's official way of doing Dots things in Unity. No, but so Dots is what Dots is right now in Unity. Oh, well, at least a year or two ago. It was several things. So one of them was they call it the job system, which is a set of APIs to do multi-threaded code inside in C#. That is different from just regular C# threads. Like it has a bunch of things that help you to avoid deadlocks and help you to manage dependencies between jobs. You could use just regular C# threads forever. Like if you want to just do everything, just multi-thread things yourself, then that worked always. But the job system is kind of a slightly different take with some helper functionality to make it more robust. Then there's the burst compiler, which is basically takes a very small subset of C# code and compiles that to speed that is comparable to C or C++. And then there's the entity component system, which is the whole ECS model of doing things, and that's and the burst and the job system were sort of production ready and used by a ton of people without ECS for many years by now. And the entity component system, we had 1.0 release, I think 2 years ago, 3 years ago. But for example, I don't know the latest state, but one of the issue with Dots was that, like, okay, so if you want to have 10,000 entities in your game or 1 million entities in your game doing something, that's fine. But then people go and say, like, oh, I want them to animate. And Unity goes like, well, you can write animation code yourself. Good luck. Or like, I want them to have audio. And like, I don't know. Yeah. So a whole bunch of systems that usually a game engine provides were not like animation, audio, I forget what else, were never were or not yet done for the Dots world inside of Unity.
This ties to the earlier question answer, because like this is such a core abstraction that it touches pretty much every other subsystem, right? And you need to redo all the other systems for now Dots way of doing things.
Right. Yes. Yeah. So for example, for graphics, they did like entities graphics, I think package is called, which provides a way of sort of super fast rendering of massive amounts of scenes that work with sort of almost regular all your shaders and materials and whatever. You just need to, if you're writing shaders manually, you just need to do some small tweaks in how you arrange your data to make it compatible with Dots. So that works, that's fine. For physics, they made a whole new physics engine that is not the same physics as what used to be inside Unity for reasons I don't know. But
okay, this feels weird, because out of all the things, I would suspect that you can have the same physics. By the way, Unity uses the physics like PhysX from NVIDIA, right?
So Unity has used PhysX forever, since version 1.0 or something. But for dots, they added two new physics engines actually. Well,
What?
okay,
What?
okay. Hear me out. Unity actually has 4 physics engines.
What?
The traditional Unity has used PhysX forever, but specifically for 2D games, it uses a version of Box2D.
Okay.
Like if you don't need 3D at all, Box2D is kind of, or it used to be at least, somewhat more stable and more performant than trying to make PhysX just always lock everything on one axis.
Okay.
Like for purely 2D games, Box2D is nice and fine. So that's 2 physics engines, right? But then for dots, they added 2 more physics engines. One of them is Havoc.
Okay.
But I think that one you need to license specially from Havoc. Like, it doesn't come with Unity. You need to, like, Havoc is owned by, I think, Microsoft now. And like, you need some sort of license to get that. And then the combination of Unity people plus Havoc people made like a smaller or lighter version of that called Unity Physics, which is kind of, I think it is data compatible with Havoc, but it doesn't have some of the features. I don't know which features it doesn't have.
Okay. And this is the sort of like main one that you would use if you were to use dot stack.
I actually don't know.
Okay. Because if you need to license the Havoc, I would guess like this is an extra step that you need to do, right?
Yeah, I guess you would use Unity Physics like this Havoc Lite,
Okay.
but I haven't been following it that much. I don't know what features it is missing compared to regular Havoc.
Okay. Okay.
Now, why they didn't do just physics and make it sort of dots compatible is a good question. I don't know. My wild guess, without having any data, there might have been some business decisions involved, some partnership with Microsoft or whatever, right? Maybe, you know, maybe at the time they made the decision, the future of physics itself was unclear or something. Like,
Yeah. Okay, this I get. Like this on the business side, I can wrap my head around.
right.
Like
Yeah, but basically that's how you end up with 4 physics engines. And again, sort of, you, in this case, you partially ship your org chart, partially ship your business relationships to your users, I guess.
you ship everything at the
Yeah.
company. Okay. On the note of the new renderers in Unity, now I think the most recent announcement is that they will actually merge. But generally speaking, there is this like old renderer, and then there's the universal render pipeline, and there's the high definition rendering pipeline. And as far as I understand, the idea was that we can make a scriptable rendering pipeline so that you can have your own steps in the rendering. So you can have your own shaders and you can create your own rendering pipeline with your own, for example, post-processing effects and generally speaking, whatever you want to do in the pipeline. And this is like a sort of hidden feature. I don't know, like if you go to universal rendering pipeline, you just have like here's a page, like use this, here are settings, you can have like post-processing and stuff like that, but it doesn't advertise that like, look, you can tweak the process of the rendering and have your cool shaders and way of rendering that will be stylistic and things like that. Like it's not the main focus. So what can you tell me about this, like inside Unity reasons of building new rendering pipelines and then having this weird split, and then what's going on?
Besides that, Let me try to find an alternative to a word that would start with a cluster. Train wreck? Train wreck. Train wreck is... I mean, in my mind, it's not a success story in how the render pipelines happened. Or to some extent, even why they happened. From what I remember, we made a decision to make the whole render engine sort of scriptable or modifiable because people kept on asking for more flexibility, and we were exposing like various hooks and settings and callbacks and whatever out of the existing render engine, and at some point it was just getting sort of too complicated. Now, you could argue that like the people who were asking for this would be teams that are very technical and have people who can write a graphics engine or whatever, or modify a graphics engine. So an argument could be made that if only source code would be available for cheap or to everyone, then this whole problem wouldn't exist because they could just modify the engine as they wanted. I'm not sure how much that is true nowadays, but back in like Unreal Engine 3 and to some extent Unreal Engine 4 days, it was very common for large productions to in some cases even completely throw away the graphics engine and just write their own engine. And so they would use essentially Unreal for some of the systems that are fine for the game and for the tools. But for example, there's been a ton of games that are made with Unreal that don't have the Unreal graphics engine. Yeah. That is probably less of a case now because especially at AAA scale, making your own graphics engine is a massive, massive, massive investment. Yeah. Anyway, so if you don't have source code that is available for your customers who need to modify the engine, I guess an alternative is to make the engine sort of kind of available as source code in terms of we'll just move it to C# and ship it to the users, and then they can modify it as they want, right? So that was part of the reason why we did all of this. The other part is that, at least back then, when like live hot reload C++ tooling didn't exist, iterating on the graphics engine itself when it's written in C#, when inside of Unity you can just recompile, you don't need to pre-launch the whole thing. That was faster to some extent. And then we started developing this whole abstraction and what things need to stay in C++ for performance reasons and what things need to be in C#. And the whole scriptable render pipeline thing came to life, and the APIs for that were designed. And unfortunately, the whole burst thing was happening in parallel, but it was nowhere near being ready. And that's the reason why, like, the API design of the whole scriptable render pipeline thing doesn't even use burst at all, or at least it didn't for many, many, many years. Because initially burst didn't exist. And later on, like, they couldn't make it a required dependency, I guess. I think by now they actually require burst for some of the things. And now the other things that happened were that initially we were not sure whether this whole C# rendering engine can even work. So we started 2 prototypes internally. One of them, can we make a super small, very minimal render pipeline that does very, very, very few things but it works on the lowest possible hardware, or like back then sort of mobile VR device or whatever. And at the same time, another team started an experiment led by Sebastian Lagarde, like, can we make something that is sort of a high end, and can this abstraction, can we make a render engine that is high end with this whole thing? And I think our mistake was that these two prototypes or experiments to learn whether this thing is possible ended up shipping to users and are still shipping like almost 10 years after the whole thing. In retrospect, what we should have done is that, okay, like they spend like whatever, half a year experimenting this, then we learn what is missing and what is not, and then we gather again and sort of say, okay, now let's do this for real. We have the API that we know what is needed from the API perspective. Let's do the actual thing. But there were a lot of sort of also things that I probably shouldn't talk about that are not technological, but more like dealing with people is hard. So there were a lot of factors that ultimately led to these two render pipelines actually shipping to users. And yeah.
So now if you start a new project, you can select between the original / old pipeline, and you have shaders that work within those, or you pick one of the new scriptable rendering pipelines, universal high definition, and you need to adapt your shaders. If you have some shaders from the past and you want to use them, you need to adapt them. And also, like within the scriptable rendering pipeline, you can do your own rendering style. So this is, I think, to the point you raised at some point in the past. It's like you have now so many things and decisions to make when you create a new Unity project. Like back in the day, it was just like, here's a project. And now it's like, okay, do you choose this or this flavor of this part, right?
Yeah.
No. Was there attempt to consolidate this on the rendering part and other subsystems, for example, we mentioned physics and generally dot stack? Is there an attempt to, let's say, get to this sweet spot of like, here's an engine, everything works, don't worry about it, here's the way to do it?
Yes and no. I mean, whether people internally at Unity realize that this is a problem, yes. Whether they do enough to fix it, no. So, for example, about render pipelines, there has been like an effort in terms of, I think it's like called unification or whatever. As far as I remember, it has been going on for years. Possibly restarted several times, and possibly no one who goes into that effort sort of comes out alive or whatever. No, what I noticed is that everyone who tries to do that eventually leaves Unity. Like coincidence, I don't know, right? I think at the last Unite, they finally actually announced that in some unspecified future version of Unity, there will be just one render pipeline. Now, does that mean that it will be, for example, just universal render pipeline with some extra features and the HD render pipeline will just go away? Or whether they will get actually merged, or whether they will be a new incompatible render pipeline with the three ones that exist? I don't know. From what I can tell from the social media and LinkedIn and whatever, almost all the people who used to work on a G render pipeline are no longer at Unity.
Okay.
Now, it is getting some small features and small improvements. So someone is still working on it, of course. But I think majority of the team has moved on for various reasons. So what they will actually do, I don't know, right?
Okay.
I hope it will get to a point where a user has to make fewer decisions at the start of the project, and overall everything will become simpler. But we'll see.
Okay. Now, I'd like to ask you about Unity going public. How things changed? Because I worked in a company that went through this process and a lot of things changed. And I was wondering, for the game engine side of things, when you're working on this kind of like, I feel it had to be also like psychological change to first work in a company that's like engineering, making games, yeah, let's go. And then it's like business and now shareholders and everything is like, okay, now it's coordinated effort. We need to hit that growth. How did the transition look like and what was the effect?
Oh, so what was your case when the company went public? Like, did it drastically change things?
It made data to access to data a bit different. So, for example, now you were insider when you were having the access to the data because you could derive things. So a lot of things that you could normally maybe share, you couldn't share. And there was a lot more pressure to, let's say, do things in a certain way, like deliver. Like the public relations aspect, I would say, was much more scrutinized. And, you know,
Okay, but like the actual culture within the company, did it change all that much or not?
it probably varies team by team. This was more like a technical platform where I was working, so it was like as far detached as possible, but still, obviously, like working with other teams, like the pressure has spiked for all the people that were like client facing and delivering things to the client that is visible.
I mean, within Unity, I don't think it was like a drastic sudden change. I think at least for several years, if not more, before the IPO actually happened, it was pretty clear that the company is trying to go to IPO. Yeah, you could say that even for like, I don't know, 6 or 7 years before the IPO happened. So like on the day of IPO, like nothing drastically changed, especially since I think employees inside the company have like a lockdown periods when they cannot sell the stock that they have or whatever due to or possible insider trading or things like that. But over all the years that the company was going towards IPO, like the whole culture and a lot of things, yes, they have changed. Now, how much of that is due to going public or how much of that is just due to pure growth? That is hard to say, right? I guess part of the growth is also driven by desire to go to IPO. And in Unity's case, especially after the IPO, I think up until 2020 or maybe 2021, at some point I looked at how many acquisitions did the company make during like each year, and I think in like 2018 or 2019 it acquired like a lot of other companies. Now some of these acquisitions are very small, and some of these, like the Weta, are fairly big. Uh, uh, And at least to me, looking at some of these acquisitions was more like like we are buying this, like why does it make sense? Uh, and but I mean, I'm not a business person, so either I don't know, or the strategy for some of these acquisitions was not much more than we are doing something. And back then, sort of funding was essentially free anyway, so you can just spend infinite amounts of money. And uh, at least to me, at some times it sounded like the strategy of Unity was essentially, we're going to hire everyone and we're going to do everything. And that's not a great strategy, I guess. Or especially, it's not a great strategy when funding becomes no longer free and infinite.
Oh yeah.
As many companies have found out, actually.
Did this erode culture within Unity? There's like high growth, a lot of people coming in, no time
Yes.
to train.
Yeah.
Okay. When you look back on your time within Unity, what do you think of as the high moments? Like when was the cool time to work there? What were you doing then?
I guess depends on like, especially at the beginning, it was exciting, but also fairly stressful at times. Like, my memory is actually, like, I don't actually remember this, but the CEO used to tell me that, like, oh yeah, like, there were cases when we missed the payroll by like a month or whatever, right?
You don't remember?
No, I don't remember.
Okay.
But at least back then, I like, my expenses were not that high either. So I was never in a situation where, like, I cannot afford food anymore or whatever. But it was fairly stressful in terms of there was a lot of things to do. The financial situation was sort of breaking even, but barely. So it could have been that, like, if 5 more people buy Unity this month, then we're good. But if 5 fewer people buy Unity this month, then we're done.
Okay.
And at some point, it was stressful due to external competitors or external factors. For example, at some point, Microsoft announced something called XNA. I don't know whether you know that thing. So initially, no one knew what it would actually be. They made like 3 real-time demos of like a car, a tiger, and something else, and no one understood what these are, except it's something to do with game development. Eventually, they made like XNA Game Studio, which was a way to make games for Xbox without having a dev kit, which was a big thing back then. And you could write games in C# and with a fairly nice API and whatever. It wasn't an engine because it didn't have tools besides Visual Studio, but it was a nice set of sort of program-oriented APIs for making games. And that was a scary moment, at least to me, because they were very clearly going after the indie market with a free tool, and it's Microsoft, right? So a tiny company, you cannot compete with that if they focus on this properly. Turns out they never focused on this properly, which is a thing that large companies tend to do. So in the end, it wasn't a serious competitor. The other scary thing I remember back when Flash existed, and towards the end of Flash lifetime, they added 3D support to Flash.
Oh.
Almost no one noticed because Flash died almost immediately after they added 3D support for unrelated reasons. But
Yeah.
they added 3D support, and again, if they would have focused on this or done this properly, that because Unity's main sort of motto was like it's like Flash but 3D, right? And suddenly Flash has 3D, then sort of yeah, so that was also somewhat scary, but eventually turned out
Okay.
But I didn't answer your question. What was the high
Because
point?
I thought it's gonna be like, oh, what are the funny moments or like happy moments? And you're like, oh, I have only PTSD moments, like only the scary moments.
I wouldn't say it's PTSD, but these are moments that are memorable.
Yeah, of course.
For me, like happy moments, one very nice moment was that when we shipped the Windows editor version, which was like I and two other people were sort of working on that for over a year, and sort of because that opens up the user base of Unity to like, I don't know, easily 10 times more people, because like now you could like quite a decent chunk of people use Macs, but back then it wasn't the case. So that was nice. One very nice memory is when I worked on one of the first Unity demo productions. But that, like, the actual demo wasn't good or anything at all, but that was in 2012, I think. But we worked with an actual movie studio to make the content and the story and everything, and we tried to make the technology for that to work. So what was developed during that demo production became the basis for Unity Direct 3D 11 support and compute shaders and all of that. And the sad thing is that I think the compute shader abstraction that is in Unity today is still largely the same, which doesn't make all that much sense to me.
Okay.
So that was nice. It was very nice to work on the initial Metal support for graphics for Apple platforms. But some of that I cannot talk about because it involves Apple, and some of the work that was done was before Metal was public.
Okay.
So it's Apple things. That was very nice. But now that I think about it, all of these things were at least 10 years ago.
Okay. What have you worked on done more recently?
Before I left for 2 or 3 years, again, I forget. For several years, I was leading a team called Quality of Life team, where basically what we were trying to do was to fix various annoyances in the product that often fall between the cracks or between the teams.
Okay.
So especially in a large company, you often end up saying, like, animation team is saying, this isn't ours, this is graphics, and graphics team is saying, this isn't ours, this is animation. And effectively no one fixes that, even though it's annoying for the users. So it was a team of 5 or 6 people, and we actually fixed a bunch of things or improved a bunch of things all over the place, like whether that's like editor user interface improvements in terms of workflows, or speeding up certain things, or just polishing things. So that was actually fairly nice as well.
Yeah. Yeah, it must be satisfying to fix things that are that are there for years and are annoying, and then you come and you just finally manage to like get the teams to agree to accept either responsibility here or there.
Yeah, and
exchange.
especially since at the time most of the engineering effort was like put into dots and sort of building the future of Unity or whatever. And meanwhile, you have this product that already exists that everyone is using, and the fancy future didn't happen yet. But no one is improving the current situation.
Yeah.
So yeah, that was nice.
Okay. Why did you leave?
Multiple reasons. I think it took me about 6 years to actually leave. Like, it wasn't a sudden decision. I started thinking about leaving a long time ago before I actually left. And part of that is just because the company became very big and very complex. And to some extent, the product became big and complex as well. And that just became less fun to work on it and more like a oh no. And then I wasn't sure whether the strategy of the company or the product itself made all that much sense. As I mentioned previously, at times it seemed like the strategy is basically let's try to do everything, and in my mind that's not a great strategy.
Okay. Now, not to leave the Unity topic on that sad note, I want to ask about the community forums in Unity. Maybe this is a sad note as well for you, but that would be a bad decision. Okay, but I feel like the community forums, they had their kind of own community. Like there were so many people that were very helpful, both from Unity, but also people that are not working in Unity as Unity employees, trying to help other people answer them questions, even if it was like the question was asked like 150 times already, and still people have like patience to answer them. What can you tell me about the forums from your perspective?
My memory of the community forums is also very good up until some point. I think it is very hard to scale a community forum with a growing user count, because and that was one of the fears, for example, when we made the Windows version, right? Like, oh, we'll have 10 times more people suddenly asking for help, right? Or when we made the free version of Unity, again, 10 times more people. And many people would say like, oh, various noobs who don't know anything about how games should be done or whatever. I think at some point the whole scale of the forums just became too big for people both inside and outside of Unity to meaningfully track and contribute. Probably some of the culture shifts inside of the company played a role as well, because with more specialization and sort of more teams that are managed by someone or produced by someone or scheduled or whatever, right? The more it becomes more like a scheduled machinery, the fewer sort of happy accidents happen. And just randomly deciding to spend half a day on forums answering questions is, it's a decision that you can make if no one tells you that you shouldn't be doing that. And at some point, everything became so much sort of schedule and Jira driven that there's no Jira ticket saying randomly decide to go to forums today. At some point, several years ago, they also moved the forum backend from the traditional forum to, I think, Discourse now. And for me personally, that's when basically I stopped going there or writing there, because I'm too old for Discourse. Just like I don't understand Discord, I don't understand Discourse either. So maybe I just don't understand anything that starts with a dis.
Okay. Well, do you have anything to say or share on the Unity front, on the discussion, to close out the Unity part?
To make it like you have like a positive ending, or
I think it was quite positive. Like, we're in the middle. You can go both ways now.
No, I hope that Unity can get out of the current slump and sort of get back to being a nice and pleasant to use and easy to use and highly polished engine for that doesn't try to go after AAA or doesn't try to compete with Unreal in their home turf, but tries to target, I guess, smaller game development projects. But I do realize that is a very hard problem, and I think Unity at this point is still the most widely used engine ever out there at all. So there's not much experience at all in the world in how to continue developing an engine like that. No one knows how to, like, there's no blueprint, to borrow the Unreal terminology, to follow. So you can just wish them good luck and hope they find a way. But what is the proper way to do that? That is a hard question. I don't know.
Okay. Now, in the more recent years, after you left Unity, you've been doing a lot of open source contributions and work, for example, in Blender. So maybe on this note, can you do an overview of your work? What have you done? To what projects have you contributed to, and why?
Yeah, so with Blender, I initially started to contribute there in file import and export area, specifically for the old file formats that still exist for some reason, like OBJ. So I spent some time there, and for the past 1.5 years, I've been mostly focusing on the video editor feature set, which is a feature that Blender has that almost no one knows about because they don't advertise it that well. And frankly, it's not that great, or not that great yet, or something like that. It's fine for some workflows. It's still terrible for some other workflows. So I think this year, they use it inside the Blender studio. Like, Blender has a development team and they have a studio as well, which makes short films. And the setup is that the studio kind of always uses the latest Blender version to try new features and to drive development of the new features. So sort of dog fooding type of situation. Most of the Blender developers who actually are employed by Blender, not all of them, but a large part of them are literally working from the same sort of building as the studio is. So it's a very tight feedback loop.
Okay.
So that's a nice setup. Now, Blender Studio, I think it uses the video editing tool set mostly for storyboarding, and it's fine for that workflow. Like it's okay. Uh, but for other types of video productions, where you might need like more like transitions, effects, text, whatever, right? Um, um, it's bearable, but that's about it. Anyway, so I've been doing a ton of performance optimizations in that project. Some of the sort of user interface polish.
Can you break down? Can you break down a little bit how Blender works under the hood? Like, what are the components? So when you say optimization, to which specific part are you referring to?
Optimizations that I did on this project were either within the video editing toolset itself, for example, making various transition or effects that you could apply to your video content, like glow or blur or whatever, like a crossfade, right? Various of these effects faster, or for example, it was the case when you have a complex video timeline with, say, like 10,000 video clips or whatever, right? Like a whole movie storyboard. And it used to be the case that if you zoom out and see just everything, then sort of it repaints at like 5 frames per second, which is not very nice. And now I think the same test that I used is like at 60 frames, which is much more interactive. Some of the other things I was doing, which tie into video editing feature set, but also are useful for everyone else who uses Blender, is, for example, rendering into any video file is now faster due to various things. Blender internally uses FFmpeg for reading and writing video files, but there were a lot of overheads on the Blender side, additional sort of overhead compared to just what FFmpeg does. So I've been doing that, but also lately been doing a lot of things that are kind of that I notice while doing something related to video, but are not directly within the video feature set itself, like something about like image loading or various operations that you might happen on images. I just notice them because they occasionally pop up in video, but they're not strictly only within the video feature set.
When you would like try to extract what are the common optimizations that you happen to do, is it more like memory management, putting things into proper data structures, or making use of cache? Like, what's happening there?
The primary majority of optimizations that are the most impactful is noticing something that is stupid and making it less stupid. And that is the case. Like I saw someone commenting of like if you make something like twice as fast, you probably did something clever in terms of some sort of low-level optimization or whatever, something smart. But if you make something like 100 times faster, then you just fixed some stupidity that was there for no good reason, right? So a bunch of things I did was just sort of purely just profile some actual workload and just see what are the slow parts and look at them and sort of try to decide whether they're slow within reason or they should be faster. And I guess after many years of programming experience, you develop a bunch of intuition in what is the expected performance of things. Like you could, the way I started to work on the file import and export of OBJ in particular, like I remember loading some pretty large file, and it was taking, I don't remember, like 10 seconds or whatever, or a minute or something like that. And I was like, oh, this is slow. And one reaction could be that OBJ is a very old and ancient text-based format. Of course, it is slow because it's text, and you need to parse all the numbers from text. So of course it is slow. But then it was still like 20 times slower than it should be. Uh, Even if it's text or anything, it's just sort of, you can, in many cases, you can do some very rough estimations of, this is reading this many gigabytes, you know, doing this many very hand wavy sort of
Yeah.
operations or whatever. Or people would say, oh, of course, it's just bottlenecked by disk speed. But you just go like, no, SSD speed is this many gigabytes per second. I'm loading this many. So, of course, whatever, right? So most of my optimizations were just looking at things that are slow and, oh, like, oh, whatever, this effect on the video clip is not multi-threaded for no good reason whatsoever, or this is, many cases happen where, for example, you allocate a bunch of memory for some temporary image inside a video processing chain or whatever. I found many cases when it allocates the memory, then it clears the memory, and then it immediately overwrites the memory with the new data, right? Now, on small enough size, that doesn't matter because like it fits within the cache and whatever. So the initial memory clear is not a big problem. But like if you're working at like 4K resolution at like HDR content, that is like 100 megabytes per frame or something. So it's no longer the neatly. So even like the pointless memory clears are a measurable performance impact.
Do you often drop into assembly to actually see what are the instructions and how much they should take in terms of time and cycles?
No,
No.
no.
Okay.
I mean, once in a while, yes, but most of the optimizations I did on Blender and at Unity as well. I mean, the very first ones are just fix stupidities, or like fix accidentally quadratic complexity algorithm, or uh, so once in a while, yes, you drop into assembly and see what is like at the assembly level. If it's some very particular inner hotspot loop that, but you do that after the stupidities are fixed.
Oh yeah. Oh yeah, you don't want to look at the assembly instructions of stupidities. Uh, and then
Yeah, because there's many of them, and all of them are stupid.
yeah, okay. How
Though
do how do you
I'll just do like a topic jump. I did some programming for the Playdate,
oh
which is a weird device. Uh,
yeah.
and for that, I actually looked into assembly quite a lot because it's like a computer from '97, so it's not very fast, and you cannot afford to do many stupidities to begin with.
Yeah.
So yeah, again, depends on your platform and on your product.
How do you start um, contributing to Blender if Blender itself is a huge project? How do you, what's the mindset of yours? Like you can profile a thing, see, okay, this should be faster, then you open this
Mhm.
project and it's huge. What would you recommend for people how to
It, it
start?
it's actually much smaller, and it I was surprised in like, because it has a lot of features, right? It's a full-fledged 3D uh, application, like with modeling and animation and several rendering engines and um, video editing. Uh, um, so I was surprised and at how relatively small the code base is, and how, again, relatively easy it is to start. Like how easy it is to build it yourself, and then the actual contribution process was very sane and sort of sensible. But again, I mean, I've had years of experience working in at Unity, which is a several times larger code base. So if you have a code base that's, say, like 5 million lines of code, and then you go to a code base that is 2 million lines of code, you're like, oh, nice, smaller, right? Yeah.
It's true.
So I guess if someone doesn't have experience working in large code bases, it might be intimidating or confusing. But if you do, then I don't know.
Okay. Is there anything that you would like to add on the open source contributions? Oh, I would like to highlight your project of running Doom within video editor in Blender. It was awesome. There is a blog post of yours where you describe how to run Blender with just coloring the bits in the video editor. This was super cool. How much time did it took? And yeah.
I think it was like a day or two. I mean, no, like that particular project was easy because so in Blender you can write scripts in Python, right? And Doom, being Doom, of course, it has been ported to everything. And I found this someone else like wrote a Doom renderer in pure Python with no dependencies, nothing. Like it was like Python is very concise language. So that was, I think they made it on purpose. That is like 666 lines of code to render Doom in pure Python. So it's, and since there's no dependencies and the input, it gives you basically the image back as a byte array. Yes. So you use that. You just feed the colors into the colors of the sequencer strips, and you're done. It doesn't run very fast due to reasons that are within Blender itself. But I hope that sometime this year or next year it will run much faster because of completely unrelated work that we're going to do about video editor caching system and whatever. That is the bottleneck right now.
Okay.
Because right now, for every change of the color of any strip, it does fairly complicated work of trying to invalidate related caches of composited results and whatever, and that is slow due to complexities and whatever. And now, of course, within any reasonable use case, that is not a problem, because like if you click on something and change the color of it and whatever, and then it takes like a millisecond to flush the caches, that's fine. But if you want to change 10,000 of them all the time, then
yeah, it poses a problem. Okay. What would you recommend for newcomers to the field now? I didn't ask you about your opinion on AI tools like ChatGPT to help coding. What would you recommend for people to start with and to become a sane developer and have reasonable understanding of programming?
A sane developer. Okay, then you would have to ask someone else. I don't know. I mean, for me, it was very easy, I guess, because right from the start, I knew what I wanted to do. And that was like something with computer graphics, right? And if you do something with computer graphics, then there's not that many choices. You either go to games or to films or to some research, scientific visualization or whatever, right? Now, back then, films industry that would use computer graphics didn't exist in Lithuania. To some extent, it still doesn't. Games were just starting to exist, and the scientific aspect, I think I didn't realize is an option back then. But for me, it was easy because I knew what I wanted to do. If you don't know what is actually interesting to you, or you don't know what you want to do, then how to pick that area, I don't know. I don't know. Then I guess sort of you could try to see what would be useful if someone did that or something like that. But I never had that problem. So
Find your
don't
interest
have it.
and pursue your interest.
Yeah, that sounds like a motivational poster somewhere. Like
Exactly. Okay. Thank you so much. Aras, thank you for your work at Unity. Because Unity lowered the bar for a lot of people to make games, and awesome games were created with Unity. And this is directly your work. You can rake in the profits from all the cool games like Outer Wilds and Obra Dinn, and all the other games made in Unity, or Songs of Conquest, one of the recent one. Have you played it?
Mhm. No.
Oh, okay.
Okay.
Do you like Heroes of Might and Magic? Have you played the games?
No, actually, no.
Oh.
This is one of the series that I didn't actually play.
Okay. So Songs of Conquest is like a new remake done in Unity that perfectly writes the nostalgia vibe of heroes from the past, but done in a fresh new way. But I guess
Okay,
you
but
don't have
if I
nostalgia.
never played, yeah,
Exactly.
yeah.
Okay. What games do you play?
Right now, I don't actually. Uh, I,
What games have you
I guess
played?
I guess. Well, okay. I actually played a bit of the new Indiana Jones that just came out several months ago, just purely to punch the Nazis for a bit, and it's good. It plays well, but I don't know. Like to me, it got boring after a while, so I stopped playing it. But
Okay.
that's the most recent one that I played.
Okay. Okay. Then again, thank you so much for your work, for your open source contributions, and for coming to chat and discuss Unity flaws and advantages openly with me. Thank you so much.
Mm-hmm. Okay, you're welcome.